Hello, welcome to Introduction to Programming in C, a little overview of computers, programming, and software development. So in the computer, your computer system is made up of hardware, which is all of the equipment like your memory and your CPU and all of the devices that connect to your computer, and your software, which is all of the programs that run on your computer. And we, in this class, are going to learn how to write programs. And we're going to learn how to write programs using a language called C. And it seems like this just seems really, common sense, but it's very specific. And since it is a machine, it's very important that you learn the rules on how to instruct the computer what to do. And while you're in this class, keep in mind that you are giving instructions, and this is a computer, and we are going to use a high-level language called C, but the computer is going to follow the instructions that you're telling it to do. So sometimes it seems like you think you're telling it to do one thing, and it's actually doing something else, but it's really doing what you tell it. It's a machine. So we're going to learn how to understand how to provide the instructions, and in addition to understanding how to give the instructions to the computer, we also need to follow rules of this language C that we're going to be using for this class. All right, so in the components of the computer, the important part to understand here is that everything needs to be loaded into main memory in order for the CPU to access it and process the data. So we have main memory, which is, in other words, is called your RAM, random access memory. This is managed by your computer, by your operating system. So you don't really need to worry too much about how it's managed, but you do need to understand how things work in order to get a better understanding of what's happening when you write programs. So when you write programs, you're using this high-level language to give instructions to your computer. And your computer has to process data in order to make things interesting, obviously. So the data must be stored in main memory for the CPU to access it. So throughout the class, I will be drawing many times a memory map, which is just a representation of your RAM or your main memory. And all of the data that is put in there is going to have an address. Now, something to remember is that one time when you run a program, some of the data that you put in that program will be at a particular address. Now, if I take that same program, the same instructions, the program instructions and the data, and I take that code and I put it on my computer, the address of all of the data is going to be different because my computer is doing different things than your computer. Or if you stop running a program and then you come back and load it again another day, the address or the location of the data is going to change. You don't need to worry about the location of the data because your operating system takes care of that for you. But what you do need to know for this class is that all of the data is located somewhere. Somewhere in your RAM is where the data is placed. Now, the way that we access it is not by the address or the number of the location, but we give names to our data so that we can use a language that's much more like English to understand how to give the instructions to the computer. So this is an example of a memory map. So this just represents your RAM. So this would be a memory map that's representing a little portion of the RAM of your computer. The contents are the actual values of the information that's in there. The address just means where it's located. So it's going to be located somewhere, and the memory cell is going to be the correct size for the type of data that is there. And the data, if it gets changed, for example, if this data right here was 354 and the value of 10 were to be added to it, this would change to 356. So the data is the stuff that's inside of memory. Now, we don't actually access the data by saying go to address 1. What we would do is we would give a name to this. So we would have a name, maybe this could be called number, And then in our language C, which we're going to be using, we would always access this particular data that's at this particular location by this name called number. Or this could be a name called letter. Once again, this would be, we would declare this, we would get a piece of memory, we would be prepared to use it, and we would always, in our language C, use this word letter to describe this information that's located at this location. And this is, right now we're not getting in detail of how to write the language C, we're just going over the fact that all letters and all numbers and all data that we use, which we're going to start out by just using small amounts of data, of course, must be stored somewhere in memory in order to be accessed and processed by your processor. So throughout the course, I'm going to be drawing memory map examples. So my memory map examples will be very similar to the one just shown. It'll be just a rectangle broken up into a bunch of sections. And we will be dealing with 3 particular data types in this class. One is an integer. So if I say like int number, and I give it a value of 25. And we're going to go over more about how to declare variables and all of that. This is just an overview of memory. So what's going to happen is your operating system is going to go through memory and locate an empty space. So it's going to have this empty section right here, and it's going to have a location, which is the address. This is the address where it's located, and the contents is going to be 25, but we're only going to care about how to access it by the name that we gave it. So we gave it the name number. So we're going to have 3 different data types, so I might as well show them to you now. We have integers, we have doubles, so I'm just going to call this one X and give it the value of 54.6. So once again, your operating system is going to find a location in memory to store this for you, and it's going to be X. It will be at this particular location right here, and it will have the value of 54.6. And we'll do one more data type, which is a character, and I'll call this character letter, and I'll assign it the value of F for FAU, and your operating system will find a location to put it in, maybe right here, and it will have the letter F, and the name of it that we will use in our program would be the name letter. So it's important to just realize that all data has to be stored in memory, but each time it's not going to be in the same location. So if we use these same variables in a different time, on a different computer, on a different day, they might be in a whole different location. So it's not important to know the exact location where it's located. It's just important to know that it does have an address. Each and every piece of data that is in your program has an address. All right, so let's talk just a little bit more about random access memory. This is volatile memory. That means that when you turn your computer off, it's not persistent. Data retrieval is done by copying contents from memory into other areas of storage. So if you turn on your computer and you have files, or information that needs to be processed, then it can be copied into main memory. The important thing to remember is that you need to have main memory store your data, and that's where your CPU gets the information. And when we write our programs, we declare regular names for our data that we're storing, and then your operating system takes care of where it's placed. Another thing that could be interesting to take a look at would be to go to this website here, stack versus heap memory, and take a look at this link, and there's a very good description there of stack versus heap memory, and I will put that link onto Canvas for you guys to read about how programs are stored in memory and how the stack is used to temporarily store information while your program is running. All right, a little bit more just about the CPU. The CPU is the one that does all of the operations on the data, so it needs to fetch the instruction and the data from main memory in order to process the information. It uses registers to do this. These registers are very high-speed memory that are located inside the CPU. And a computer that has more than one CPU is a multiprocessor computer. So these things are important, but as far as we're concerned in writing our programs, we just need to know that all of this is really being taken care by your computer and your system and your operating system. And we are just going to focus in this class on declaring our data and accessing our data and manipulating our data and using the C language to create programs and solve problems. All right, so I'm sure you all are familiar with what an operating system is. It's a software that runs on your computer that is a manager. But the thing that's unique about the operating system as a manager is that there's all these resources in your computer, like your memory and your CPU and all of your devices, and everything needs to be organized and managed. And the operating system, in order to organize and manage all of this stuff, must also use these things because it's a running process as well. So that's a very interesting idea. That the way computers work, that like for example, if sometimes a manager might have his own station in order to manage what's going on around him. Here, an operating system has to share all of the resources with everything, all of the other processes or applications that are running on the computer. So it has to share all of these resources. All right, so there are different types of languages. What we are focusing on in this class is a high-level language. The high-level language is a programming language, and this programming language has a lot of English words and symbols and is easier to understand than machine language, obviously, which is binary number codes, and assembly language, which is very dedicated to processors. But a high-level language is independent of what computer system it's running on. So a language like C and C++ is good for people who want to build applications, and it is English-like, so it's a little easier to understand. All right, so we're going to be using in this class a compiler. I have a whole another presentation on compilers, but a compiler is also a program or a software that runs on your computer, and it takes your source file. So the thing that's important about the source file is to realize that it is just a text file. It's just a text file. You can open it with Notepad. You should not have to worry about any extra formatting, even though we use a compiler that has like pop-ups and things to help you. The actual source code itself is plain text. It's plain text, and it should not have any kind of things in it. Another thing is that there's syntax. So there's going to be very specific rules for the C language. So while we are also learning how to program and do everything else, we have to make sure that we are following the rules. And if there's ever any question about the rules, we have these nice compilers that help us. That's this compiler, which the compiler we suggest for this class is Visual Studio, or some version of a C++ compiler. I will go over that in a minute. So what happens is you write your source code, and you use your compiler, and your compiler takes your source code and makes sure that it's all correct, and then it turns it into an object. And then it takes that object, and there are other objects that you might need. So like, for example, you're not going to write the code on how to print to the screen or read from the keyboard. So these are already made. So what happens, it's going to link your code, which is the problem that you're trying to solve, with the other stuff that's going to help you to do that, like read from the keyboard and write to the screen, and link it all together and create an executable application. Or since we're on Windows, this is an exe file, or in other words, a running application. So we are going to create running applications. I have an example for you, an exe file that is posted onto Canvas that you can, as long as you are on Windows and you connect to the engineering student desktop, there's very clear instructions. You can download it and try it out and see the kind of things that we're going to be working on in this class. All right, so what we're going to have to also learn how to do is how to get the data into our program and then get the data onto the screen. So the way that we input data into our program is by using a function called scanf. You're going to be using it all this semester. And the way that we display onto the screen is by using a function called printf. So we're going to tell the computer what we want to scan, what type of data we want to scan into. Scanf is going to scan that data right into memory, right into a location in memory, and then when we're ready to print it onto the screen, we're going to use a function called printf, which is going to take that data that we have and print it onto the screen. If we don't do input and output, we're going to have not very interesting programs because you're not going to be able to follow what's going on. So we want to make interactive programs that scan in, okay, which is also called reading. Another term for scanning in could be reading, could be called standard input. We are using a C standard language, and printf, which another word is writing onto the screen, or standard output. So this is just a little bit about what we're going to be using. We use Visual Studio for this course. It's suggested, it's provided for you. You can use different compilers if you want. The compiler is only a small part of Visual Studio. Visual Studio is what's called an IDE, or an integrated development environment. This is an entire software package that comes with everything. It comes with a word processor, and that's where you create your source code, which is the word processor in Visual Studio is very robust. It has pop-ups and color codes and all this other stuff, but the actual source file is just plain text. Like I said before, the format of your source code is just plain text. So then the compiler is going to go through the source code, make sure that the source code doesn't have any syntax errors or that it can figure out right away. And if it doesn't, then it's going to create an object file. This object file will then be linked with other object files in order to create an executable file, which in this case for this class, like I said, is a .exe file, or another word for that is called an application. An application is a running program. In this class, we are going to be doing applications that are console applications. So we're going to be making console applications, and there is an example again on Canvas that you can play with from an assignment from a different semester. And console applications are not very exciting because they don't have forms and beautiful things. They're just a plain simple window with input and output, but there is a lot of things to learn along the way, so we start out with console applications in this course.